My student will be sharing the screen in a minute. First of all, I'll just like to say, so I have turned on my camera. I'm not sure whether you are able to see my stream coming in. Is my video working fine? I don't know. I'm asking you. It should be.
Yes,
Yeah.
sir. It's all fine. We can see everything properly.
Okay. All right. Thanks. So first of all, I mean, Balaji, you are able to hear me, but I don't know whether the team at CDAC.
Sir, I'm not able to unmute.
I'm speaking. I believe all others are able to hear, most probably. I'm not sure. The speaker connection. Let me check.
So just a minute, sir. We are checking our speaker.
Yeah, thanks. All the online users are confirming that you all can hear me. So let's give them a minute. Once they fix the speaker issues, we can get started. Any luck?
Yes, sir. It's audible now, sir. Please continue, sir.
Okay, audible clearly now?
Yes, please.
Okay, all right. Okay, thank you, everyone. First of all, a very good afternoon, and I apologize. I was supposed to be in person with all of you at CDAC. Oh, is my voice screaming around in the room? Is it? I can see some people putting the hands on the ears. Was I too loud? Well, let me try to speak softly from my side. I don't know. So I was supposed to be with all of you in person at CDAC. My apologies for not being able to come in person and be with all of you. And thank you for accommodating my request to be online. Am I coming through clearly? Is it audible clearly?
Yes, sir.
Yes, sir. Okay, thank you. So I have brought along with me one of my students who recently graduated. And it so happens that the invitation for this talk also came from Dr. Balaji from CDAC, and the student who is with me, his name is also Balaji, the one who is going to help me do the presentation today. So the topic that we have chosen is, we have chosen how to emulate the entire domain name system and the DNS over HTTPS on a single machine. Because one way that people have been doing these kind of experiments is by using virtual machines. But spinning virtual machines on a single computer can be very heavy. For example, if you want about 15 to 20 virtual machines to be put up, your one system probably would not be able to handle those resources. So what we have done is we have used something called Linux network namespaces. Balaji will be talking about it. And using Linux network namespaces, we have emulated the entire DNS architecture. And the purpose of doing this is because a lot of people are nowadays working on DoT, DNS over TLS, DOQ, DNS over Quick, DOH, DNS over HTTPS. And we wanted to create a playground for them so that they can play around with these kind of tools and they don't need to spend money on infrastructure or need to have multiple machines to perform these experiments or spin off multiple virtual machines to perform these experiments. So Balaji, can you start sharing the screen? Let's see whether you have the access to share it. I'll confirm once you have it. Yeah.
I'm showing a Google slide. Is that visible?
You can go into the presentation and I'll hand it over to you in a minute. Yeah. So like Balaji has given the title, DNS and DOH in namespaces. Yeah, Balaji, can you go for 1 minute for the agenda slide? Yeah, be there. So we'll be briefly talking about what are namespaces, particularly network namespaces, because in Linux kernel, we have about 8 different namespaces. Even C groups are there, right? So we are not going into that area. We are going to particularly talk on namespaces. All of you have been already listening throughout the day for DNS, so we'll not spend too much time on that. But then we will show how we have used bind9 and set them up in a single computer, multiple network namespaces. Then we'll talk about what is DNS over HTTPS in a quick one slide. Then show how we have used core DNS as a DOH server. And then we have an inbuilt utility which we have developed at NITK, which is open source utility, which is available for free for anybody to use and contribute. That utility is called Network Stack Tester. And we have made Python APIs for simplifying experiments on DNS and DOH. Balaji will be giving you a walkthrough of that as well. So Balaji, you can go to the first slide back again on the title slide. So Balaji Naidu actually graduated this year itself. He will be coming on November 4th to NITK to receive his degree. He graduated from Department of Electronics and Communication. I belong to Department of Computer Science and Engineering, but he was working with me on an industry-funded project wherein we were using DNS, DOH, and Linux network namespaces. So he worked with me for about 10 months, and he has a fantastic grip on the subject, and he has a demo ready to show to all of you. So I pass it on to Balaji. Balaji, you can take over from here. Over to you.
Thank you, sir. Just checking with everyone if I'm clearly audible and everyone can see my slides.
Yes, yes.
Yeah.
You're audible, sir. Yes.
Thank you. As Mohit sir mentioned, I graduated from NITK this year. And yeah, we'll be, I think we covered the agenda on what exactly we are going to discuss. And I'll try to keep it hands-on as much as possible. And if anyone has any questions, feel free to interrupt and ask me anytime. Yeah, we'll start with what exactly network namespaces are. So network namespaces are basically abstraction over particular network resources in the kernel. Say, for example, when you have installed Ubuntu on your Linux on your laptop, you get certain things like a particular network interface card or the network stack itself, right? Where the packets come, it will take a particular path, and it will have certain data structures and basically other network resources for one particular laptop or one particular operating system. And if you want to use if you want to keep isolated network resources, say for example, you wanted to test something on 10 different machines, it's not very feasible to either get 10 physical machines and interconnect them with say Ethernet cables, or maybe using a Wi-Fi or something, or even spin up VMs, because that's going to be costly. So instead, namespaces is a inbuilt technology in Linux kernel, which is integrated with the mainline Linux kernel itself, where it abstracts particular network resources and isolates everything from each other. It's basically like a box inside your Linux kernel, which can't see the other box in the same space. So it will create its own networking stack completely, and it will isolate everything from the host network. So once you create a network namespace, and if you are inside the network namespace, it can't see any of the other networking resources which is on the host machine. Say you had 5 different physical network interface cards on the host machine, but once you're inside network namespace, you can't see any of those five network interface cards. So and this is one of the main technologies used in containers these days, be it Docker, LXD, all these uh, container technologies, right? They want isolation from each other so that you can run thousands of containers on one physical machine. And main selling point of container is you need isolation. You don't need interaction from one container to other. Of course, you want interaction from a different way, but not the process themselves interacting between each other. So that's network namespaces. Yeah, I have added a quick slide on a visual slide on what a DNS query, how a DNS query looks like, right? I think you have been listening to DNS from morning, so I'll not spend much time on this. But basically, to just give a overview, whenever you do a query, it will go to your local resolver first, check if that's present in that in the local resolver's cache. If not, it then the local resolver says, okay, this is my name server, or this is where my DNS server is present. Can you fetch the IP addresses from there? Then it goes to the name server and it checks if it's present there. If not, it goes to a root name server asking, can you find IP of example.com? Then root server says, okay, I don't have the address with myself, but I can point you where you should get, or where you can get the result for your query, right? So it will say you should go to a .com name server, which is at this particular address, and it goes to that particular address. It's called a GTLD server. GTLD stands for global top level domain. And when it goes to that particular uh, top level domain server, it asks, can you give me the IP of example.com domain name? Then GTLD server says, okay, it's in example.com name server, and it goes to a name server. Then it fetches the result and it travels through the stack back to your laptop or your physical machine, and you have the IP address now. So yeah, this is the entire life of a DNS query. It goes to resolver, name servers, GTLD name server, particular domain name server, and from there you get your IP address. Once you get the IP address, you'll cache it for a while based on how the record results are set. Yeah, so that was how a DNS query looks like. I have a simple visual of whatever I'm explained here, right? So I have a host machine which is connected to a DNS server called localNS, and localNS is connected to something called root name server, and root name server is connected to something called authoritative name server. I'm not sure if the diagram is very small, if it's okay. So yeah, I'm assuming it's fine, and we'll set up a similar architecture or the same architecture on Bind using namespaces. So Bind is a popular DNS server, popular open source DNS server, uh, which is actively being developed, and it gets the name Bind 9 because the current active version is version 9. So we'll set up the same architecture on using namespaces and run Bind servers on these and see. We have one particular domain called, we have added these records in the authoritative name server, and we'll try to fetch the records from this namespace. Think of this as 4 different machines, host being your laptop, local NS being your immediate DNS server, right? Say if you're using an internet service provider like Geo or Airtel, then they have their own DNS servers in their network. So this is similar to that DNS server in your ISP, and then that's internally connected to a root name server. Say for example, here I'm going to demo with a domain with a global top level domain called TCL. It doesn't exist. It's just for demo purpose. I'm using this GTLD so that no one gets confused with that. And the root name server is connected to authoritative name server where you have all the results, right? So for this particular domain name, this is the IP address which is currently mapped to. And say if I am the owner of ns1.test.tcl, then I'll have access to just authoritative name server or auth.ns in this particular diagram, where I can configure all my DNS record names here, saying uh, my domain name's IP address is this. So so to do this experiment, ideally, if you wanted to do it with physical machines, you need a minimum 4 machines. So to avoid that, we'll be using network namespaces. And yeah, we'll start with that. I have all the configurations for this on my GitHub. I'll share the link at the end of the session so that people can try out later whenever they want. But can someone confirm that if they can see my terminal?
Yeah, visible.
Yeah.
Yes.
Okay, so I'm in a folder called bind9 right now, and as you saw earlier, we have 4 namespaces, right? One was host namespace, one is local NS, root NS, and the other one is auth NS. So we have all the configurations for each particular namespace in this particular directories, and we have a shell script called env.sh, which basically sets up the architecture which I showed you here. So it sets up all the 4 namespaces. It connects between it interconnects between all the 4 namespaces and creates a proper network for us, so that we don't have to struggle with dealing it with running the commands, each particular commands to create those. I'll briefly show how exactly env.sh looks. So yeah, this is just a command to clean up all the existing namespaces which I have earlier. You need not run this always. It's just to make sure I have a clean environment before I run a test setup. Here I'm adding 4 namespaces called host, local NS, root NS, auth NS. Once I have that, I'm setting up virtual Ethernet pairs between. I'm creating 3 virtual Ethernet pairs. So if I had to show that here, this is one virtual Ethernet pair. This is a virtual Ethernet 0 VETH1, and this is one pair. So I have 3 pairs, and I'm creating those 3 pairs here. Then once I create, assume virtual Ethernet pairs are like pipes. So now you have a pipe, and you have to connect each side of the pipe with a namespace, right? So that's what I'm doing here. I'm connecting one side of the pipe to namespace called host, and the other side of the pipe to a namespace called local NS. Similarly, I'm doing with the other 2 pairs as well. Once I have that, I'm assigning IP addresses to the virtual Ethernet uh, interfaces. So I have different IP addresses for each of the interface names so that it won't clash. Again, I have added the IP addresses in the diagram as well. And once we have added IP address, we need to bring up the interface. It's similar to how you start your operating system. So you are starting this virtual interface, and yeah, these were particular virtual interfaces, and we are starting a loopback interface as well, so that if there is any connection for the interface itself, then it should have the loopback interface as well. It's the regular one which we have in Linux as well. And then I am enabling IP forwarding here, so that say if I send a packet from here to here, it should forward the packet from this interface to here. So I'm enabling IP forwarding on these 2 machines so that routing happens properly. And I'm adding a few routes so that routing is being taken care of. Uh, does anyone have any questions on this? Can I proceed further? Okay, I'm assuming there are no questions. Uh, so uh, let me clean up this. So we have in this namespace, as I said, we have all the configurations for each namespace here, and we have this directory called etc/netns, which stands for network namespace. Basically, we should keep all the configurations for whatever namespace we are trying to create in this particular path, so that when it's trying to create a namespace, say you have to override some configuration for that particular network namespace. I'm assuming you're all aware of a host file in your Linux machine, right? So this is my host file of the host machine. I have just few records, few of the default records. But say now, when I'm trying to create a namespace called host, and I want different set of let me show resolve.conf, so it will be related to DNS as well. Yeah, so this is my resolve.conf, or a configuration for your Linux machine, basically saying this is my resolver and you should use that particular resolver. And I'm saying use local resolver, which is on this IP address and this port. But say in my namespace, I want to use a different name server and I don't want to change my local machines configurations. Then you basically keep all the configurations under etc/netns and that particular host name, that particular network namespace name. So I'll just copy. I just copied whatever configurations I had in my local repo to this particular directory name. Basically saying in authns, host, local ns, and root ns are the four namespaces I create, and all the configurations for those are inside that. Now I'll try to set up the topology itself, which was this, basically creating four namespaces, virtual Ethernet pairs, and enabling enabling IP forwarding. Now to list this, you can just do IPNet NS list. So now it shows all the four namespaces which we created right now, and it has particular IDs along associated with them to uniquely identify that. So we have host, local NS, root NS, and auth NS. Now again, coming back to this, as I said, we'll run uh, bind 9 on these three machines. And assuming this is a laptop, we no need to run bind here, because bind is, as I told you again, it's a DNS server, and we'll be running DNS server on the other three, and will have a local resolver in our laptop, which will try to connect to this. But again, just to remind you, my laptop or this host namespace is just connected to this particular DNS server. It doesn't know it doesn't have any connection between this or this. So it'll whenever I make a DNS request, it should always it goes through this path and comes back in this path. Uh, yeah, let me show the configurations first on how exactly it is configured. Later, I'll show that demo as well. So first, let me show host namespace, which just has a result.conf. As I said, I wanted to overwrite name server name here, which is saying you are connected to this particular DNS server, or but whenever I make a DNS request, just fetch results from this particular IP address or this particular DNS server. You might be familiar with configuring this with public servers like 8.8.8.8, which is Google's DNS server. If you want to override your ISP's DNS server, you can do that. So here I'm just saying you should, as a host machine, you should connect to 10.0.1.3, which is this machine. And I'll start up host. So uh, you can get shells inside these network namespaces, similar to how you have containers and you can get shells there, or you have virtual machines and you can get shells there. You can run any type of any kind of command inside this particular namespace, and it will be isolated from the others. So now I have exec into, or I have gotten a shell inside this particular namespace called host, and I leave it running for now. But if you want to just see the difference, so this is etc/resolve.conf inside the namespace, which says 10.0.1.3, but I haven't exec into or I haven't gotten a shell inside shell for any other namespace here. This is on the physical machine, which says name server is this, which is local machine, but on the host namespace, the name server is this, right? So now we saw configurations of host, and that's fine. Moving on to configurations of local NS. Again, we have a resolve.conf, but here we are saying name server is self. So if you get a query with from someone outside externally, or if you have a DNS query with yourself, you are running a DNS server yourself, so you should be able to get the answer from this particular IP address, which is local host. And we have a directory called bind where we configure the bind and server itself, right? You might see a lot of files here, but many of these are just the default configurations which you get, and you don't have to change anything here. So this is just to configure localhost. Similarly, this, so you don't have to worry about this. I'll just show what are the important files. So roots.hints is one particular file where we are hinting our DNS server, saying, so we are looking at configuration of local name server, right? So this is a DNS server itself, but whenever you get a query where you don't have the results with yourself, we are trying to hint it, the root name server for you is in this particular IP address, which is 10.1.1.3. So going back to this, we are saying root server for TCL domain or TCL GTLD is in this particular address. So if you get any query for this domain and you don't have the results, just go to this IP address. And we just configure a zone here saying we have a type called hint, and the file for that is whatever I showed you earlier, the root.hints file, where we are just configuring hints for the local name server, and that is local name server. Let me just take into that and get a shell there as well. So I'm inside local name server here. It's coming to root name server, which is connected to local name server. Again, has a file folder, or has a directory called bind, inside which again we have a lot of default files, but we'll not be looking at all of those. Instead, we have configured something here called a zone called root server.tcl. As I said, this is the root name server, right? So we have a zone for this, and the related file for that is here under etc bind zones, which is here, and root server db.rootserver.tcl. If we go here, and we have one more file called db.root saying for this root server, if you get any GTLD queries, or if you also don't have the results for .tcl domain, just contact this GTLD server, which is running on 10.0.0.3, which is our authoritative name server 10.0.0.3. That was db.root. db.rootserver.tcl says again, root server is itself 10.1.1.3. This is the root server, and if you get any queries for root queries, then you should be able to resolve those yourself. So now we'll exec into root server as well. Now we are inside root server shell here. Next, moving on to authns configurations. Again, we have a lot of default configurations. Coming to the particular configurations which we are interested in, we are saying we have a zone called TCL, and its particular file is here, and we have a zone called test.tcl which is here, and gtld servers which is here. Now if we go to this, we have certain configurations here saying the name server for gtld server.tcl is yourself, and the IP address for that, or IPv4 address in particular, because we are saying a record for this particular domain is 10.0.0.3, which is authns, which is the machine which we are in right now. And for db.tcl, again, we have a root server for uh, TCL is in this particular IP address, which we saw earlier. And when it comes to one specific domain name, right? Say, for example, if I want to query ns1.test.tcl, and for a record for that, I have configured here itself. But ideally, in real world scenario, your authoritative name server will have this configured in a different machine. To avoid one more extra machine, I have just configured just for this one record. We don't have to spin up one more machine, right? So I have just configured it here. Now I'll just exec into authns as well. So now we have shells in all these four name servers, or all the four uh, namespaces which we have created. Now what we want to do is we have to run bind servers on these three and do a DNS request from this, which DNS request for a particular domain name which is present in this server, and the DNS query should propagate from this machine all the way till here and come back here, right? So let me just start bind9 server, and this is the way named, even though the project name itself is bind, but the standard name used in all the Linux machines, or the binary name in Linux machines, is called named NAMED, and -g is just to show all the output logs inside this terminal itself instead of running it as a daemon. So I have started it on authns. I'll start it on root server. I'll start it on local server, and now as I told you earlier, we have started bind9 servers on these three. Now we want to do a query from here, right? So to do a query, okay, I think the command was not visible what I ran, but I'll just run again. Dig ns1.test.tcl. Can everyone see this command? I'm just running dig ns1.test.tcl. Dig is basically a command line utility to run DNS queries. But uh, this is being taken, I mean, this is taken care for you in the browsers, in the browser itself. Basically, it will resolve all the domain name requests for you there. But now when I ran, I got a result saying answer for ns1.test.tcl is the A record for that is 10.2.1.7. Let's go back to the configuration again and see if that was the answer. So this was configured under authoritative name server, and we had said ns1.test.tcl. A record for that is this particular IP address, which we saw in the host namespace, right? So answer section says ns1.test.tcl is present here. So again, just to brief what we did, we ran authoritative name server ourselves, we ran a root name server ourselves, we ran a local name server ourselves, and we tried to query our local name server from our laptop or from our machine saying fetch me domain name results of ns1.test.tcl, and it propagated the query all the way till authoritative name server and got the results back for us. So yeah, that's bind9 configuration and how to run bind9 or bind on namespaces and get all the results. Uh, Anyone has any questions? If not, I'll move on to the next part, which is DO and running, how to run DO on, or how to run DO on namespaces
Yeah,
using
Balaji, can you
code.
hear me?
Yes, sir, I can hear.
Right. I just want to let the participants know that whatever Balaji explained right now, for example, you can see that he configured the entire topology, what DNS looks like in a single machine. And he showed a set of commands. And those who are new to Linux network namespaces, probably they would be a bit overwhelmed by looking at that there are so many commands to be written. But the good news is, as I told you, this is something that Balaji is showing raw on a single machine with network namespaces. We have incorporated all of this into our emulator, which we are developing at NITK, and we have simplified it by using very simple Python APIs. So Balaji, you can also do one thing before you go to DO. You can just quickly go through the APIs of how same thing can be done in Nest. No need to run it, because you can show the DO demo, that is more important, but just show that how same architecture what you have drawn in the PPT, how it can be done using Python program, so that the audience who is listening does not feel that this is pretty complicated, but instead they have a sense that it is very easy to achieve. Yeah.
Yeah, sure, sir. So yeah, I showed you
Not
guys.
more than a minute or two. Just quickly go through the topology and just tell this is the Python APIs. That's it. Yeah.
Yes, sir. So we did all these things using shell script, right? So as sir mentioned, you have Python APIs to do all this. So what we are trying to do here is whatever the topology which we had earlier, right? We have host, local name server, root name server, and authoritative name server. Instead, we have 4 different authoritative name servers here, and we are saying configure authoritative name server and type is bind, and name for this authoritative name server is A1. Similarly, we are configuring 4. We are saying set up 6 different networks and connect all these networks using so basically what this is trying to do is here I showed how to set up the topology itself, and we had to run get a shell inside each of those namespaces and run individual commands ourselves, right? And even configure particular namespace saying your authoritative name server, and you should have this configuration and you should have those. So instead what Nest, which is a emulator, trying to do is we have all the same things inside a 100-line file here, which has plenty of comments as well. So it has more than 50 lines of comments itself. So we are saying for A1 authoritative name server, the FQDN is ns1.test.tcl and the IP address is this. For A2, you have a different domain called ns3.example.org and IP address is this. Similarly, others as well, right? And we
Yeah.
are
So
saying,
the good part of this is that the JSON file that you are seeing that Balaji is showing, this JSON file is already provided. The user of our tool doesn't need to write it. All that they need to do is they need to probably configure the IP addresses, whatever they want, and other stuff that Balaji is showing. But the structure of the JSON and everything is provided beforehand. So that
yeah,
saves a
you
lot
just
of
have
time.
to,
Yeah.
yeah, you just have to edit whatever domain name you want and whatever IP address
And
you
that
want. You
also,
don't
if you don't want in the beginning, you can just leave it as it is, whatever we have given. There's no need for you to change it all the time. And Balaji, you can also show where is this JSON file taken as an input, so we directly take it as an input.
Yeah,
Yeah.
so we have again we have a API for that calling import JSON, and we are just providing the file name, right? And we are saying just read this file and whatever configurations are in this file, we are converting those to all the bind and configurations which I explained you earlier here, where you saw a lot of default files here, right? Lot of these, all these files are not required, so we skip all those files in the Nest implementation which we have, so that you can write as simple code as possible and you don't have to do a lot of things there. So yeah, we are just setting up all those, and we are just starting. Okay, just start a name server, just start a name server, start authoritative name servers, and even to look up the particular IP address, right? I was doing dig. I had to get a shell in host machine and say, okay, run dig ns1.test.tcl, but you can do that in the Python command itself, saying h1 is your namespace name and you're saying forward lookup, just look up this particular IP address and get me the results, and it will print it for you. So you don't have to worry a lot about how to set up bind, how to set up namespaces yourself, and how to
It's
configure all
all
those.
automated in this, and as he said, it's 113 lines, but more than 50% of these lines are only comments for people to understand what we are doing. You can see a lot of lines in the beginning, like first 50 lines are just showing the topology, and so many comments are there. So one thing that we wanted to do in this whole exercise was to ensure that the DNS emulation becomes easy. Yeah, that's it. I think Balaji, you can spend a little more time on DOH now. Yeah.
Yes, sir, sure. Yeah, so that was how to run DNS on namespaces. And coming to do, I'll just have a simple slide explaining what do is. So whatever you saw earlier, right? DNS is basically whenever you're trying to say, okay, fetch me IP address of google.com, it will create a UDP packet for you. UDP stands for User Datagram Protocol, and it basically adds all the DNS questions you have in that particular packet, and it sends to a DNS server. And whenever you receive back a packet, or whenever you receive back a answer saying this is the answer for your question, which was what is the IP address of google.com, but nothing in this packet is encrypted, right? So whenever I'm sending requests for something particular, if someone can anyone can just watch my network and see, okay, this guy is trying to go to SBI account, or he's trying to open trying to do some banking transaction, or trying to buy something online, or this is what particular his patterns look like, because your DNS requests are public as in it's not encrypted. Anyone who is on the network can see all your requests there because it's not encrypted. And there are chances, since it's a UDP packet, there are chances that your packet might not reach DNS server, and your laptop might be waiting for an answer from the DNS server itself. So people thought this was very insecure, and they wanted to encrypt the DNS packets as well. So they came up with something called DNS over HTTPS. So the underlying protocol for HTTPS again is just TCP. So you have a reliable connection there. So if even if your packet gets dropped, you have resilience so that you can get back your answer, or you can retransmit the question again asking for a packet. And very nice thing about DNS over HTTPS is the DNS request is over HTTPS, which is encrypted, and no one can see what exactly is inside that particular packet. So even if someone is on my network, and even if I'm browsing, say anything, say I'm shopping something, I'm watching a match or doing anything, they can't know what exactly I'm doing. They just see it's a HTTPS packet, but they can't know, okay, this guy is trying to go to this particular site or trying to buy something, all those things. So again, we are showing we have a local DoH proxy in your particular network, and which tries to connect over HTTPS to a DoH server. Uh, Currently, a lot of public infrastructure, or public internet providers, or big corporations have their DoH servers running publicly. For example, Google has its own DoH server publicly running. Cloudflare has its own DoH server running publicly. You can connect to those and make DoH requests yourself. And even the browsers which you have today, like say Chrome, be it Chrome, Brave, Internet Edge, Firefox, all these browsers also have support for DoH. So if you enable that option in your browser settings, it will send all the DNS requests over HTTPS, and you don't have to worry about about your privacy, or about someone looking at your packets or DNS requests from your name from your machine. Yeah, so coming to the hands-on part, we have a similar architecture or similar topology here as well. Instead, I have skipped one extra. So you can ignore the T2 application part here. You can just concentrate on these three machines, which is T1, recursive DNS resolver, and authoritative core DNS server. Earlier we had extra namespace here called local NS. I have combined T1 and local NS here. So what I'm trying to achieve here is I have configured all my DNS records over here, which is authoritative core DNS server. say t2.test.tcl is this IP address. I'm configuring this particular information on here, and from T1 or this namespace, I'm trying to send a DO request to this machine, and this internally sends a request to here and fetches the IP address, and we get IP address back.
Balaji sir, sorry to disturb you. Mohit sir, because of the time constraint, you have only 5 minutes left, sir.
Sure. Sorry. I can just go to the demo of this and
Please conclude in next 5 minutes.
yeah, sure.
Thank you.
Again, we have configurations for all the namespaces here. You just have to so I have copied all the configurations here. Now again, this is the n.env.sh is a similar script which we had shown earlier. So if I run that again, everything is configured now. Now I just have to take into authns and sorry. The name conventions in this particular is different. I think I'm calling it auth DNS instead of auth NS. So I'm running core DNS here saying core DNS and configuration. I'm providing a configuration file for that inside authority namespace, and similar to that, I'm running core DNS on recursive DNS server as well. Now, if I try to have exec into T1, which was similar to host from the earlier one, and now all I have to do is so we have this tool called DNS lookup, which will do DO queries as well for us. So earlier, we had we were doing the lookup using dig, right? But now we are saying using DNS lookup tool, get me results of t2.test.tcl from this particular DO server. The DO server is ns1.test.tcl. It should be a DNS query. And if we run this, sorry, 1 second. Yeah, so it got the results for us saying for t2.test.tcl, 10.0.0.2 is the solution. And we saw logs here as well on the authoritative name server saying, showing the record came from here. The configurations for this is in my GitHub repo, which I'll share later. So again, as I showed in the earlier demo, we have support for emulating DNS on namespaces in Nest right now. So you can just check out this branch and run the examples provided. And I have added a few useful links, like how I have written a simple blog on how to set up DNS topologies using namespaces. Anyone who's new for network namespaces can check this. And this is the RFC for DO itself. If you want to understand what is DO and how exactly DO works, internals of DO, you can read this RFC. It's a well-written RFC. And this is my GitHub repo with all the configurations. I'll share the presentation later with the organizers. They can share it with everyone. And this is a link to the previous merge request which we had. So if you're interested to run DNS using Nest, you can just do that from there. And yeah, that's it from me. So that was how to run DNS and DOH on namespaces. So yeah, if you have any questions, you can ask now.
Yeah, thank you, Balaji sir and Mohit sir. Any questions? Questions or any questions?
There is one question in the chat box, Balaji, if you want to take that.
Sure, sir. So the question is, what are the library used to implement name server in Python? So we are not using any external library as such. As I told you earlier, to create all the namespaces, the Nest itself is a tool which does create all the namespaces for you over APIs, over Python APIs. And to configure the DNS, say DNS files like be it bind9 or core DNS configuration file, then you don't need any external libraries to configure them, because all the configurations can be done in a simple file. So we are using the standard operating system, the OS library, to configure or open files and do configurations for the file. And to start the name server itself, we need those particular binaries. Say if we want to run core DNS, we want core DNS binary, or if we want to run bind, you want to have the named binary yourself. So we are not using any external libraries to implement this in Python. If that answers your questions, Nilin.
No, that's right. We don't use any dedicated Python library. We basically just use the command. We have a wrapper of Python on top of those commands to simplify the activities for the user.